So a few people had questions about analysis question 2. So analysis question 2 asks you, in order for a population to be in Hardy-Weinberg equilibrium, it has to meet the following criteria. So we know it has to meet all 5 of these things. It's got to be no natural selection, no mutation, et cetera, et cetera. So how can we prove this is true of our last model, our population of 1,000? So for each of these criteria, what I want to do is start with what is the definition of it. So I could start with natural selection is, and I know that natural selection is when a population changes over time because certain traits are favored and they give the organism a fitness advantage. Essentially, they're able to survive and reproduce. Whatever your definition of natural selection is. I'm going to first define natural selection. Maybe I can say our first goal, number 1, is define the term. Okay, number 2 is we're going to see, does our model show this? And I can ask you, like, where does our model show natural selection? Does our model show that there are certain traits that are preferred? Is it similar to an example that we've seen? Some examples of natural selection we've seen are antibiotic resistance, where certain bacteria survive because they're more resistant to a drug. Another thing we've seen are examples of Darwin's finches, where certain birds with different sized beaks survive because they naturally have an advantage. That doesn't really appear in our population, the one that we simulated. There's no particular trait. So I could say our model does not have natural selection because there is no trait that would be favored to give a fitness advantage. Something like that. And so that would be my claim and my evidence. And my reasoning would be the reason why this is true. So something like this shows that there is no natural selection in our model. Yours can be a little bit more elaborate, probably. But for each one of these things, we're going to go through and define what it is. What is a mutation? What is random mating? Extremely large population seems quite obvious. And then what is gene flow? And does our model meet this? Why or why not? And that's the answer analysis question 2.